Okay, guys, doing domain and range graphically. How I'm choosing to work this out for you guys is that you're going to do it using the translation form, not only so that I can reinforce what these graphs are and what their names were, their equations, but the whole idea of doing a translation. So remember, this was a parabola, and it went y is equal to a, x minus h squared plus k was its translation form. Hyperbola, a over x minus h plus k. This one was an inverse square. Y is equal to a over, and the x minus h this time is being squared. That's an absolute value graph, so that was an easier one to remember. And then that's a square root graph. And all of these, again, are the positive values for the square roots, sorry, for the translations, for the value of a. All of these pictures up above are for a positive value of a. So if they were going to be the negative values of a, one second guys, let me pause this. Okay, so where I was leaving that was that if it was the negative values of a, if a was negative, then what that does is it turns the graph around. So this would be the negative value, this would be the negative value, so it's both pieces. Both pieces of this one. This would turn upside down, like it did for the parabola. And then this was the positive value before, so it was the upper half. This would be the lower half. Okay? Domain is what are allowable x values. What x's can be used? I haven't tried doing cursive with this. Maybe I shouldn't try doing cursive with this. Let's try that again. But then the kids have been telling me they have a hard time reading cursive, so maybe I shouldn't. All right, so let's try this. Allowable. They haven't spelled right. Doesn't look like allowable x values. Whew, that's pretty bad. X's, when you guys think of a simple line, X's are what you put in. So what's allowable if you don't like X values, it's your allowable inputs. Let's try cursive, see if that gets any better. It's your allowable input. Correspondingly, range would be allowable, or I'm trying to get away from using the word allowable. It's what can you expect as X values? What do you get out of the equation? Okay. Now, that's kind of what the definitions are, a little loosely defined there. But what I want to do is give you some notes on how to find domain, how to find range. So when you can see the graph, you ask yourself, can the graph go as far left as it wants? Can the graph go as far right as it wants? Are there any holes or gaps in the middle? And I'll explain that as we go further. None of these are going to have any holes. Holes are literally like you took a hole punch and you punched a hole in the graph. So right now, as of today, you guys don't know, you won't know what a hole is until you get up into chapter 2. But I'm trying to teach you one way to remember it, and then I don't have to add to it later. Can the graph go as far left as it wants? Can this parabola continue to go as far left as it wants? Yeah. Can it go as far right as it wants? Absolutely. Are there any holes or gaps? No. So the domain of that graph is all real numbers. And if you guys aren't used to writing all reals like that, it's a double uppercase R, and you're drawing it off the left one. If you want to draw the uppercase R and then put another line in, that's okay. I find it easier to draw the two lines and then draw the R on it. So, all real numbers. That's what the domain is for this parabola anyways. So your domain would be all reals. This one, can you go as far left as you want? Absolutely. Can the graph go as far right as it wants? Yep. But you got a gap in the middle. The gap says x cannot be 0 because that's the value of x it doesn't take. It doesn't ever be that value. This one, can you go as far left as you want? Yeah. Can you go as far right as you want? Absolutely. But there's a gap. And right in the middle there's a gap again. So x can't be 0. And we're talking X is for domain because, again, it's the numbers that you put into it. Can the graph go as far left as it wants? Does it continue to get wider and wider and wider as you go? Yeah. Does it go as wide as you want that way? Yep, absolutely. So the domain would be all reals. There's no gaps. Can the graph go as far left as it wants? I guess I should start by going left because that's what I've been doing. Can the graph go as far left as it wants? No, it can't. Can it go as far right as it wants? Yep. Well, how far left can it go? It can go as small as 0. Oops, I don't know why I wrote y. I'm sorry. X is greater than or equal to 0. That would be your domain. You can only use x values greater than or equal to 0. Only use x values to the right. You should get rid of that. Sorry guys, not used to popping it away. I apologize for having it stick out there. Okay, range. Range is done really similar in that you're wanting to know what is what numbers are okay to use, and range is your output. It's your y values. So you're going to ask this time, can your graph go as high as it wants? Can it go as low as it wants? Are there any holes or gaps in the middle? So looking at this one, can we go as high as we want? Yeah, absolutely. Can we go as low as we want? Well, no, we can only go as far down as the x-axis for this one. So the range for this one would be y is greater than or equal to 0. Let me go back and put the domain right here with it. Okay? So on this one, can we go as high as we want? Yeah. As low as we want? Yep. Are there any gaps? Yes, there's a gap at 0. So y also can't be 0. For this black one, can you go as high as you want? Yep. Can you go as low as you want? No. We can only go down to the x-axis. Now remember, that axis is an asymptote, and you can't touch it. So this is y is strictly greater than 0. This one, can this graph go as high as it wants? Yep. Can it go as low as it wants? Absolutely. Oh, I lied. Sorry, I was thinking of a different problem. I apologize. Let me back up. Can it go as low as it wants? No, it can't go as low as it wants. It can only go as low as the x-axis. So y would be greater than or equal to 0 because it can actually touch the x-axis. Can the graph go as high as it wants? Yeah, slowly, but it does go as high as it wants. Can it go as low as it wants? No, it has to stop at the x-axis. And again, it can touch the x-axis, so it's not strictly greater than. Okay? Now those are for all the graphs that are in black. To look at what they would be for the negative value, for when a is negative, just ask the same set of questions. For domain, can the red graph go as far as it wants left, as far as it wants right? Are there any holes or gaps? Yeah, it's all good. So the domain hasn't changed. But this time, can the graph go as high as it wants? No. It can only go as high as 0. Can it go as low as it wants? Yeah. So for the negative value of a, the graph is going to be turned upside down, so it affected the range, but it didn't affect the domain. For this one, okay, so the red graph, can you go as far left as you want? Yeah. As far right as you want? Absolutely. But there's a gap at 0, so x can't be 0. Now for the right graph, can you go as high as you want? Yeah. As low as you want? Yeah. But there's a gap where it's at 0. So there it didn't affect either of them. This one, it's not going to affect the domain. You can still go as far left and right as you want. The gap is still going to be at 0. But the range, it's going to be turned upside down. So in this one, it didn't affect domain, it did affect range. The red graph, domain is still all reals. In the range, it's again going to be turned upside down. This one, the black one, x had to be greater than or equal to 0. If I turn it, flip it over the x-axis and make a negative, the domain's going to be the same, but the range is going to be less than or equal to 0. Okay, I don't necessarily think it's worth memorizing the domain and range for these. You definitely need to have the graphs memorized. I've told you that from earlier in the year. You got to have these graphs memorized. Okay, but you need to have memorized domain. Can you go as far left as you want? Can you go as far right as you want? Do you have any holes or gaps in the middle? Range. Can you go as high as you want? Can you go as low as you want? Do you have any holes or gaps in the middle? And then writing the domain accordingly, or the range accordingly. Now, practicing that. This graph is a parabola. It's pushed, remember, 4 units left. You read this opposite, 4 left, 3 units up, and it's opening down. Okay, so domain. Can you go as far right as you want? Can you go as far left as you want? Any holes or gaps in the middle? Yeah. So for domain, you're all, whoops. Sorry guys. So for your domain, I'm going to put D there to remind me whether it's, because if I just write all reals, I don't know, is that for the domain or the range? Okay, now for range, can you go as high as you want? No, I can only go as high as 3, but I can go as low as I want. So y less than or equal to 3. Okay. This is a hyperbola. It has a vertical asymptote over at 5, horizontal asymptote down at 3. And at A is positive. Let me change colors. I'll show up a little better on the green graph. Whoops. Right. There we go. That's part of it. And this is the other part down here. Okay. Can you go as far left as you want? Can you go as far right as you want? Yes, but you have a gap. Where's the gap? The gap for domain x cannot be 5. We'll talk more about later why it's 5. Range. Can you go as high as you want? Yeah, low as you want. Yeah. Okay, so where's the gap? The gap is sitting at -3. So y cannot be -3. Okay. Inverse square. Same asymptotes as the one that was before. 5 units over. 3 units down. And A is positive. So it's going to be, sorry, as I circle it, A is negative. Okay. I think I've been doing one too many videos today. A is negative, so it's opening down. Can you go as far left as you want for domain? Yes. Can you go as far right as you want? Yes, but you have a gap. Where's the gap? The gap's at 5, so x cannot be 5. Range, as high as you want? No. How high can you go? You can go as high as -3, but I cannot include it because that's an asymptote. Y is less than -3. Hepsidiagram, 3 units left, 2 units down, it's opening up. Domain, all real numbers. There's no gaps. They can go as far left as it wants, as far right as it wants. Life is good. Range, can you go as high as you want? Yeah, as low as you want? No. How low can you go? -2. And it's opening up. Y greater than or equal to -2. Okay, square root graph. Let's keep 3 units right, 7 units up, and A is positive, so it's the upper half. Domain. Can you go as far left as you want? No. How far left can I go? I can go as far left as 3. So x is greater than or equal to 3. Range. Can you go as high as you want? Sorry about that, you guys. Can you go as high as you want? Yes. As low as you want? No. How low can you go? 7. So y goes out. Sorry about that. Greater than or equal to 3. It's going over. Now, what I need to do, just reiterate before they change pages. Domain, you're asking yourself, can you go as far left as you want? Can you go as far right as you want? Do you have any holes or gaps? Again, I was going to explain gaps in chapter 2. So you got a little bit till you understand, holes in chapter 2. Gaps are going to be created by asymptotes. Range, can you go as high as you want? Can you go as low as you want? And you ask yourself again, do you have any holes or gaps? Okay? Once you can see these graphs, once you can look at them, then you can find the domain and range. Looking at it here, for graphs that you don't know the equation, don't worry, you still use the same 2 descriptions or the same 2 tests to find it. Does it look like this graph will go as far left as it wants? Yeah. As far right as it wants? Absolutely. So the domain would be all reals because there's no gaps either. This graph looks like it's heading out like this. It's starting here and here. Can you go as far left as you want? Yeah. Can you go as far right as you want? Yeah, but you got this big old gap in the middle. So how about if I use the interval notation? I'm going to come from -infinity up to negative 3. And I'm going to include negative 3 because I'm making the judgment call that that does include the value. So that's a bracket. Then I'm going to go from 3 off to positive infinity. Okay? If you don't like it in interval notation, how about this? For your domain, x is less than or equal to negative 3, x is greater than or equal to negative 3. Okay? This one's starting here. I'm going to assume it's whole numbers. So it looks like 3, 1, 2, 3, 4, 5, 6. So it's about negative 6, 3. Domain, can you go as far right as you want? Yeah, as far left as you want? No. How far left can you go? So for your domain, x will be greater than or equal to negative 6. So I've only done domain so far on these. Okay? I'll come back and do range in just a second. Okay, this graph continues to cycle like this. It continues to do this. Can you go as far left as you want? Yeah, as far right as you want. Yeah, absolutely. So your domain looks like it's all real numbers. Okay, you got a horizontal line. Can it go as far left as it wants? Yep. Far right as it wants? Yep. Any holes or gaps in the middle? Nope. So it's all real numbers. Here's another line. Can it go as far left as it wants? Yep. Can it go as far right as you want? Yep. Any holes or gaps? Nope. So the domain is all reals. So talk about range now. Can you go as high as you want? Yeah, as low as you want? No. It looks like the lowest you can go is 1, 2, 3, 4. What do you think? So for range, y would be greater than or equal to 4. Now, do I know that it's equal to it? Nope, I don't. I'm just making that judgment call from the picture. Again, I made the judgment call that it equals those points on the end. So range, y would be greater than or equal to 0. Can you go as high as you want? Nope. How high can you go? I can go as high as 3. So range, y would be, because it's going downward, y is less than or equal to 3. Now this graph is trapped between, it looks like 1, 2, 3, 4, 5, 5 and negative 5. So the range, y, whoops, I don't know what I'm trying to write there. Your y value is trapped between negative 5 and 5. Can the graph go as high as it wants? Nope. How high can it go? It can only go as high as 3. So y can only be range 3. This one, can the graph go as high as it wants? Yeah, as low as it wants. Absolutely. No holes or gaps, so your range is all real numbers. Okay? You guys are going to get how to do domain and range algebraically soon, but for right now, you're just doing it this way.